Okay. Open the quiz.
Yep. Did you guys did the questions already?
Well, that's what I wanted to review some of the questions, because there's some of the questions I'm not getting.
Yeah, but you already went through them, right?
Oh yeah.
Good. Okay.
Yeah, the questions it said are the exact same in the quiz.
Yeah.
So
Well, I guess
let's just go through
we'll do it
the
together.
quiz and then it can go over it.
Well, number one, we're meeting with our group. Number two, which of the following variables is our categorical?
So a randomly selected brand of toothpaste.
Why wouldn't it? Because you got to do a process of elimination too. Why wouldn't the number of animals in the local zoo be categorical?
Because it's number, it would be numerical.
Thank you.
Yeah. One example that kind of helped me with that is if you change, so like one question was like if there's a football team and you're getting like the jersey numbers, that would actually be categorical though, because if you change the jersey number, it doesn't affect the outcome type thing. I don't know if that makes sense.
I like that. That's a good way to look at it.
So that kind of helped me be able to. But then did you guys choose age and years of randomly selected vehicles?
Sorry, I'm still opening the quiz.
Oh, sorry.
Oh, you're good.
Mm-hmm.
All right. So, sorry, number two was the toothpaste, right?
Yeah, I'm just making sure it's not age and years of randomly.
I only put number two down is what I put. I put the second one down. But age and years of randomly selected vehicles in a parking lot would be. These aren't the exact same questions, are they?
They are, but they just started with number 3.
Huh. Okay. Yeah, I mean, that's what I would put.
Okay.
Okay, number 3.
So 100 would be the parameter. And then 112 would be the, oh wait.
Oh, sorry. I couldn't figure out what I wrote. I was like, what the heck? So the parameter is 100 and the statistic is 112?
Yeah.
From the notes, it talked about population equals parameter and sample is statistics. That's what helped me on that one.
Oh, I like that.
Population parameters. So the mean of the population is 100, where the mean of the sample is 112. So sample for statistics, population for parameter.
I like
Okay.
how you did that with your thinking.
So number 4. Oh, it's annoying that all the numbers are off.
Yeah.
I put stratified sample.
That's me too.
I also put stratified sample.
I did as well.
Oh, good. Okay. I was like, I wasn't sure if, I mean, you can maybe do a cluster, but it just stratified seemed like it would make made more sense to me.
Yeah.
Because you're working with a stratagem within a stratagem, so to speak. But there's different stratagems, so.
Gotcha.
And then next one,
I
cluster.
put cluster, yeah.
Okay.
That was on number 6?
Number
Yes. No, 5.
number 5 was cluster.
Number 5 here in our test is when designated experiments are conducted in a public school system. Researchers typically choose a particular district and randomly select teachers of, say, 4th grade students of that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented?
I put cluster.
Yeah, because a cluster, the definition of cluster is when you organize it and then do into groups and then do a simple random sample of each group.
Yep.
I wrote it in ink.
Yeah. Whereas stratified is you just choose everybody in that group, not a random sample.
And then 6 is a simple random sample.
Yeah.
Because the questions aren't matching with our questions.
Yeah.
Yeah, it's one off. So 6 on the quiz
Is 7 on our,
is 7 on our sheet. Yep.
and that is 7 is a, I put,
Simple. What would you guys put?
I put 7.
Yeah.
What number is that on our?
Sorry, let's always just refer to the question on the quiz.
let's always repeat the question here.
So at a school fundraiser, the name of every person, that question, number 6.
Yeah.
Who attended, who was entered into a drawing at the end of the evening. 6 names were selected to receive door prizes. Which type of sample scheme is implemented? I put a simple random sample.
Yes.
And then number 7 on the quiz.
I put stratified.
Me too. And that's stratified because we're selecting the 2 different groups, right?
I
And
got
then taking
stratified
a
too.
simple random sample from those groups. That's the definition of stratified. Correct?
Wait, stratified is you choose all of that group or you?
So you're taking
Stratified,
2 different
stratified.
groups and then taking a simple random sample of each group.
Okay.
under the summary in lesson 2, it says a stratified sample divides data into similar groups and an SRS is taken from each group.
Yep.
Gotcha. I had it mixed up earlier.
Yeah, earlier when you read that, I was like, man, that seems like she's reading the stratified answer or the definition.
Yeah, I think I just mixed up the 2.
That's all good.
Sorry.
Okay, so number 8 on the quiz.
I got 4.771.
4.771. So,
I also did that. A survey was taken of purchases at the crossroads. Open the data file crossroads. And our number 9, their number 8 would be calculate the descriptive statistics of the amount spent at the crossword purchases. Give the mean, standard deviation, and 5-number summary of the data. So you would take all the numbers in that, and then you would divide it by 1, 2, 3, 4, the 5. That would get your mean.
Yeah.
correct. And it makes it really nice if you put it into that Excel spreadsheet. Because then that Excel spreadsheet that gives you your standard deviation and everything, it also gives you the Q1, Q3, and just gives you all 5 numbers right there.
Yeah, the minimum, the Q1, medium, Q3, and maximum.
Yep.
Yep.
So for
standard D. Oh,
go ahead, McKenna.
did you guys get 1.912?
Yep, 1.912.
Yeah.
Is that question number 9 then?
Yeah, number
Yeah.
9 is 1.912.
1.912.
That's what I got.
That's what I got too there. Okay.
I did.
Instagram.
Yes, I did. True. I like that Excel because it automatically creates the histogram.
Yeah.
Yeah.
Yep.
Information. Jessica Meyer and her research team measured the body temperatures of samples of diving elephant seals. Site mirror 10. A thermistor was placed at a specific location on each seal to measure its body's temperature. The body temperature of seals tend to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal.
So for this one, so we're back to what our questions are.
Yep.
They match. So I got negative 0.17. Well, no, negative 0.165.
We got to round it up. Oops, I guess we didn't. I didn't round it
Yeah,
up.
I thought we did, but we didn't.
So it's negative
1.165.
Can I say it again? You're reverberated there, Myra.
0.165.
0.165.
Negative. Make sure you put the negative.
I would have gotten that wrong because I rounded it up to 2.
Yeah, I did as well. Oh, is Brian there?
Sorry, guys.
Kind of blinked out there.
Goodness.
You taking a blink on us?
Seriously. All right. We're on number 11. Sorry, did you guys do 11?
Yeah, we got negative 0.165.
165. Awesome.
Okay, number 12, I got 0.681.
I didn't round it up again. 0.6689.
I got 0.681.
That's what I got as well.
0.681.
Oh, man. So my computer completely exited out of
Your test?
my entire window.
No.
So I have to reopen it, and I'm sure now I only have one chance.
Unless it saved it.
Unless it saved it. Oh, crap.
Do you save your questions as you go?
Nope.
Oops, that's why you got to save them as you go, Brian.
No, I don't. Crap.
I better go back and
Hopefully-
save mine.
I can rewrite them in. I just hope it doesn't count as a try.
An attempt.
Nope, it didn't. Oh, yes, 1 attempt in progress. Okay, continue quiz. Look at that.
Perfect.
Computers are smart.
You're last.
Awesome. It's because we said a prayer at the beginning. That's what it is.
Of course. It's the Spirit helping us.
All right.
Miracles happen when you
That's
incorporate
right.
the Lord.
All right, just catching back up here. I'm going to save them now.
Yes, that's the strategic thing to do, Brian.
Let's see. This is a
You know,
close-
Nephi used strategy, you know. Captain Moroni used stratagem. We got to use stratagem.
That's right.
So did you get number 12?
Number 12, I got 0.681.
Okay. That's what we. And then number 13. I didn't know the answer to this one. Did you guys?
I got B.
Variance is what I got, but I'm not sure. I put a question mark by it.
So did I.
Just like I'm still filling in questions real quick. I'm catching up. I'm getting there.
Because variance is part of that equation to get the square deviations. Variance equals S. So you guys kind of ferreted out. We need inspiration in this.
I have no idea.
I'm almost there.
Because it asks the number 13. What quantity is equal to the sum of the numbers in the squared deviation columns? A, the mean, B, the standard deviation, C, the variance, D, none of it is correct.
It's the standard deviation.
Okay.
So if you to do a standard deviation by hand,
Oh, shoot, we lost him.
I think what he said was true because what you're doing is you're taking x minus x bar.
Yeah, I agree too. That's what I had written down with the question mark next to it. Because I kind of vaguely remember it being like the mean minus the value squared. But I have no idea. Or the value minus mean.
Come on, Brian.
guys, this is getting ridiculous. I'm sorry. I'm just talking to myself for like 3 minutes. Yeah.
Did you lose your
I don't know.
quiz again?
Oh, I sure hope not.
But at least you saved it this time.
No, I didn't lose it. It just cut out for some reason. So it's the standard deviation.
Okay.
Explain it.
So if you're looking at the table for A and B that we already did, right?
Yeah.
So the steps to doing a standard deviation by hand are you have to find the mean, and then you subtract the mean, and then square the results. So that's basically what this whole process is doing. You're finding the deviation from the mean. So you're subtracting the mean from the Bodil or whatever the seal. So the first seal, you're taking A. You're finding A. and then you find it in B in the square deviations column. That's going to give you what your standard deviation is. That's going to tell you the standard deviation, basically.
Okay, that makes sense.
Thank you for explaining that.
Because I feel like that's what that whole chart is basically showing you, taking you step by step and how to find the standard deviation. At least that's how it makes sense to me. But.
Okay. So then number 14, what is the standard deviation? I got 0.1 or 0.715.
Um, 0.715. That's correct. Yes, sorry.
And I didn't round it up. I had 0.7151. So yes.
0.715.
15, I got false.
Yeah, that's blatant. And that was in lesson 3, summary 5.12 to reference that, because it says the standard deviation cannot be negative.
Yep. Awesome.
Perfect.
16. Which location results in the most consistent temperature measure? I put extradural
I did as well.
because it has the smallest standard deviation.
Yep, that's what I put.
Well, 16 here. Hold on.
Myra, I just want to make sure you're getting all this right.
I didn't hear you. What did you say?
Are you understanding? Do you have any questions about any of this?
No, I'm just having a question for the next one.
You have a question on the next one?
17.
Okay.
Let's go over 16 again. It says
I didn't get
which location resulted in the most consistent temperature measurements from one seal to the other? I thought it was the extradural.
That's what I put.
That's what we put,
Okay.
because the standard deviation is the smallest.
And then 17. So Myra, you had a question on this one?
I didn't know how to do it.
Okay. So when given a box plot, like the one given just above the question, so the first little line on it that corresponds with number 2 is going to be your minimum. Then the next one that corresponds with the number 4 is going to be your first quartile, so Q1. And then the solid black line in the middle corresponds with 6 is your median.
Okay.
And then the one that corresponds with number 8 is your Q3, your third quartile. And then the line all the way out that corresponds with number 12 is your maximum. So whenever given a box plot, those are always the same values. They may be shifted around or whatever, but it's always minimum, quartile 1, median, quartile 3, and then maximum. So so what would number 17 be? What would be the Q3?
0.577.
For 17?
It's 8.
It would be 8.
Yeah.
Yep, correct. 8.
Did you get why, Wanda? It's 8?
No, because I probably misinterpreted the question. Can you please review it?
Yeah, so this is 17, right?
17 on the quiz, correct.
Correct. So what he was saying is that you look at the box plot and you start reading it from the left.
Mm-hmm.
So if you're reading it from the left to
1,
the
2,
right,
3. That's the third quartile.
so the third quartile is, do you see like that center box with the black line in between it?
Yeah, that's the medium.
The black line's the median. So the next line to the right,
It's
that's
Q3.
next vertical line is Q3, which would be 8.
I get it. Thank you. And thank you for explaining it.
No problem.
Question 18. What percentage of the data lies between 4 and 8 hours? Note, list the number as a percent, not a decimal. Don't include the percent sign.
I feel like that's different than what it asked in the other one.
No.
Yeah, I think it asked 4 and 8 on the other one.
Yeah, I think it was, the last one was,
It correlates with question 19. It says,
so it would be 50%, right?
yes,
Yeah.
but it says don't put percent. So we're going to have to put 0.50, right?
Just put 50.
No, just put 50.
Okay. Because it says do not a decimal.
Yep, not a decimal or not a percent sign. So then 19, estimate the mean.
So it'll be 20 on our quiz.
Yeah,
Or on our homework.
gotcha. So 20 would be, what's the mean? What did you guys get?
So I wasn't sure about this one, but I got 2.055.
Yep, I got 2.054.
I got 2.055.
Okay, I must not have rounded that one up right.
How you get the answer?
So for that one, you add the two values, the 1.59 plus 2.52, and divide it by 2.
By 2.
Okay.
Yeah, we're usually used to strings of numbers to add in our problems.
Yeah, that one confused me for a while. Because it was just too simple. Can't be right.
So the answer is 2.055.
2.055.
Yeah.
Right?
Yeah.
Because you add 1.59 plus 2.52, you divide it by 2. So do it on your calculator. So you get
We
the,
lost Brian again.
Guys, my internet stinks. Goodness.
at least you have longevity. You keep on coming back to us.
That's right. I'm moving to a different little spot in the room, so hopefully this works better. You explain 19?
Yeah, we explained 19 and now we're on 20.
Explain how you got that one again. You added them up and divided by 3?
By 2.
By 2.
Divided by 2.
By 2? I did.
Yeah.
I did it some
that what
other
you did as
weird
well?
way, but it worked out. But that sounds like a better way to do it. I actually sat and thought about that one for a while and came up with some weird way to find it. I got it.
Yeah, I did that as well.
Well, they give you a lot of information.
Yeah. So add them up and divide by 2. Gotcha. So you're adding the 1.59 and the 2.52 and then dividing by 2?
By 2, yes.
Okay. Awesome. Learn something new every day, that's for sure. All right.
I hope that's right. I don't know that that's right, but
I feel like that is right.
It's got to be. If we all got
agree.
pretty much the same answer
yeah.
and got it going about different ways, it's got to be right.
There you go.
So 20, standard deviation, 0.233.
These are ones I didn't understand, but now that I'm looking at it,
Okay.
it's making more sense.
I got parentheses 2.52 minus 2.005 to the square with a underneath it then a square 0. 216225. Get it in circle. Which
Heard
one?
of that? Wait, are you explaining how you did it or the answer?
I was explaining how I got it.
What
Oh,
answer
gotcha.
did
Okay.
you get?
I got two
I
answers
didn't
here.
get it.
The zero, it's asking what the standard deviation is.
Correct.
So the square of 0.43245 equals 0.6576. That's a standard deviation. But I really need to go through the math, because x equals x over square. It's x minus, what's the little x with the line over it? X square, x box, x.
I don't
I can't remember
but I know
the
what you're talking
technical
about.
name for it, but
X minus x box with a square. So our 2.52 minus our 2.55 square over a square of I have to redo this.
so I did it a weird way. I don't know if this is the right way to do it. This is the way my brain figured it out. I can't remember why I thought that this would work, but it works. I took the 2.54 and I subtracted the 1.59 to give us like and then divided it by 4. So we're 2 standard deviations above and 2 below. So if we figure out what that difference is, that gives us a total of 4 standard deviations. Then I just divided that by 4 to give me 1 standard deviation.
Oh, I see.
Does that make sense? I'm pretty sure that's not the right way to do it, but that's the way my brain figured it out. So I got 0.233 for the standard deviation. And if you add that twice to the mean, it gives you 2.54 or 2.52. Sorry. So it works.
Yeah. So it would be the C. Then you have to
Oh,
subtract
sorry.
it as well.
I wasn't even. Sorry, yeah. So standard deviation was 0.233. Are we on 21?
We're on 20.
Yeah.
I'm on 20. With my
Oh, I
calculator.
skipped one. I'm sorry.
It says,
So what did you say you got?
For
So
20,
you
I got
finished in
0.233.
Okay, yeah.
and what about John?
John, I'm putting that off till tomorrow because it's getting late anyway.
You're gonna call him and give him
I already
the
did. I just got off the phone with him.
Okay, bye.
So then
Okay, so 21 is C then?
21 would be is C, correct?
What
You
is
just add and
20?
subtract.
I got distracted.
20 is 0.233.
2.33?
Yep, 0.233.
I'm getting my decimals wrong.
So the reason, so I did it a different way and I got the same answer. But what I did is I just, in the equation, the mu minus 2 standard deviations equals 1.59, I just plugged in the mu, the mean, and then I just did it, so I subtracted 1.59 from each side and added, like,
Solved it algebraically.
Yeah.
That's probably the best.
And I
way
got
to
the
do
same
it.
thing.
Tell me the equation again. 1.59 plus the standard deviation.
No, it's the equation they give you up above in the example. You can plug it into either one, plug the
Yeah.
mean, and then
Give me
solve
the-
it out.
Can you give me the equation?
It's in the
that
question.
mu. Yeah, it's in the question.
Mu?
The ones that are bolded.
That's definitely a better way to do it. I wrote out the equation to find the mean, and I was like, wait a second, we have two variables here. That's not going to work. And then I totally forgot to go back to the equation for the next question and figured it out some weird way. So that's probably a way better way to do it.
So McKenna, can you tell me the equation again so I can write it down?
So I can't really say it because you're not going to be able to write it right because I don't know how to say it. But it's the one in the exam, in like the very, like the main question, that big
Just
paragraph.
above question 19.
Yeah, you can use either of those equations and you'll get the same answer if you plug in the mean for that U thing.
You'll have to email it to me.
So Wanda, scroll up just a little bit. So you're on, so scroll up to question 19, right? You're looking at question 19.
19 would be estimate the mean of the measured nitrate.
Yeah. So go just above question 19, and it has the whole, an observation from a normally distributed population, that paragraph.
Yes.
In that paragraph, if you look from at the bottom of the paragraph where it says, we will assume that the mean minus 2 times the standard deviation equals 1.59, that equation, that's the equation she's talking about.
Okay.
So since we've already found the mean, we can put the mean into that equation. So it would be the mean minus 2 standard deviations equals 1.59, and then solve for the standard deviation. And that would give us the standard deviation. Does that make sense? So that's
great.
the equation she's talking about.
Yeah.
So
thank you for explaining that.
Plug it in and then you solve it algebraically. Do you want to go through it real quick?
I do. I need to go through it.
Yep. So if we use that at that first equation, so our mean is 2.055 minus 2.
Oops. We lost our Brian again.
Well, I'll keep explaining it. He's better at explaining though. But for our mean, so for that U, you plug in the mean we got, which is 2.055 minus 2 standard deviations equals 1.59. So you add to each side of the equation, you add 2 standard deviations. So you get 2.055 equals 1.59 plus 2 standard deviations. And then you subtract, you're trying to put the variable by itself. So then you subtract 1.59 from each side. So you get 2.055 minus 1.59 equals 2 standard deviations. And then you divide each side by 2 to isolate the standard deviation. So then you get standard deviation equals 2.055 minus 1.59 over 2. And then you solve that out. Did that make sense?
It's a long process.
Yeah.
You there? I lost you for a second again, for crying out loud. Did you guys go through it? I was like solving it all by myself, I think, because no one could hear me.
Oh, dang it. I did finish going through it with her. Did that make sense, Wanda?
I have to work it out, and it will.
I'm going to go downstairs and maybe get better internet connection. I'm tired of this cutting out thing.
So question 20 is 0.255.
No, just 2.055.
0.255.
No. 2.055.
2.055.
Yeah.
Question 20.
All right. Hopefully I get better internet connection down here. I'm in the kids' playroom, so hopefully it works. It's kind of crazy messy, you can tell.
They got positive energy.
All right. So does that make sense to everybody?
Did that make sense, Wanda?
I already did that, but I don't know how I got it. I'm kind of like Dory with this. I do it and then I forget it.
As long as you can do it, because then when the question arises later, you'll be able to do it. So that's good.
Yeah.
That's why I need the equations, you know, in the process, because I can figure it out. It's just taking the time to do that.
Yeah.
All right. So 21, we got D.
C, right?
C, 1.590 and 2.520.
You're
Wait.
adding 1 standard deviation.
Is that what you got as well? Because it would be 1 standard deviation away, right?
Correct.
Okay.
So that would be I got it
It
should
would be D, wouldn't it?
1.823 and 2.288, right?
Right. Yeah.
So it's the last one. D.
Yeah. I said it wrong. Or did it wrong. Do you understand how to do that one, Wanda?
Between the two measured nitrate concentrations do approximately 68% of the data value list. Are we using the X box for this?
You're using the 68, 90, whatever rule.
And so when it's 68, remember it's 1 standard deviation away. So you add the standard deviation that we got in the previous, in 21, to the mean. And then you subtract it from the mean as well. And that's how you got those two numbers.
It's the 68, 95, 99.7 rule.
Roger that.
All right. Then 22. Probability.
For this one, I got 50%. But I think I'm way off.
Oh, so this is 23 in our actual. Yeah, I didn't know how to do this one.
So for what I did is I just found the z-score, and x I put 542.3 minus the mean, which is 542.3. And then I put that z-score into the probability applet and then did above, which gave me 50%.
So finding the z-score, you're gonna put that, because that value 5542.3 is equal to the mean, right?
Yeah, so
you're
for the
just
z-score,
putting
I
that
got
in
0.
as the mean and then dividing it by the standard deviation.
Yeah, and I got 0, but I don't know that I did it right.
I did the z equals the n minus the mu over the standard deviation, which is 500 minus 402.3 over 120.54. So the z-score I got was negative 0.359, which I put in my applet.
And that gave you what?
It gave me 0.3628 for the probability or the area.
Sorry to bother you, but Sarah wants to know if any mail came for this.
Can you say that equation again?
The equation is the z-score, n minus mu over standard deviation. So our n is 500, our mu is 542.3 over a standard deviation of 120.54 equals the negative 0.359 for our z-score. So when you put that into your z-score, come on z-score, negative 0.3509. The only thing is, I always have issues shading which area here. So I shaded to the left, and my area is 0.3628. You guys got your applet open to do that?
Yeah, I'm just going through it real quick. No, please, bud. Oh, in your mouth. Hey, Ash. Everett has something in his mouth.
So for the applet, did you get 0.637 then, Wanda? For the area? Oh, she's gone.
So, McKenna, I guess I don't understand. Can we just put in, not subtract it, and just put in the mean for the top number?
I don't think so, because I don't think that's the z-score equation.
Because if you subtract it from itself, it's going to equal 0.
Yeah, so I'm thinking that's just kind of what I got, but I was thinking it was wrong.
Because if you do it without subtracting, and you get a z-score of 4.499, which is basically 100%. Or it is 0. I don't know.
When I did it Wanda's way, I got 64%.
But if you think about it, like logistically, what's the probability of a student scoring the average?
Yeah.
It would be like almost 100%, right? If that's the average.
Oh.
I don't know though.
I'm sorry. I had a. What did we get for the answer for 22?
We're still working on it.
Okay.
What did you get?
That was the 0.363 if you round it up.
How did you find that?
I did it by the probability. When you read probability in your questions, that means area. You got to use the applet.
Yeah, absolutely. So what numbers did you plug in to get your z-score?
I plugged in 500 minus 542.3 over 120.54. Because if you look at the above problem there, the standard deviation is given as 120.4, so that's your standard deviation. Your 500 is your BYU number, and your mean is your 542.3. Do you see that in the information there above us?
Yeah, but I don't understand why you would use 500.
Yeah.
What are you using as your n?
That's the question I have, is I don't know what to use as an n. Because it's not asking, technically the n value is 542.3, which is equivalent to the mean.
I'm plugging it into my z-score. The z equation is n minus mu over standard deviation.
exactly. But the question itself, the n value that it's asking is not 500. The n value is 542.3. Which,
When you,
if you put that in, that's the same as the mean. So it's basically asking what's the probability that a randomly selected student will score above the mean on the GMAT. Am I wrong in thinking that?
No.
it says the minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500.
Correct, but the question 22 isn't referring to that 500. It's not asking about that 500.
Our N is either the 500 or the 600, but it is rare for the students to score less than 600 to be admitted. So my N, what I chose was 500.
I don't know.
Yeah,
You have your information in your.
My guess is that it's 0. If you get a z-score of 0, yeah, so it's 100%.
But this is
Because if you put 0 into your z-score, it gives you 1.
and then did you click to the right because it's above?
I put it to the left because it says scores less than 600, so it's going to be to the left.
You need to look at the question, not the. It's saying select will score above 542. We lost him again. Oh, there he is.
I'm talking to myself for 5 minutes. Sorry. I'm going to a different spot of the house. We're crying out loud. I'm going to get bombarded by kids, but I'm going to sit right next to our router. So,
It's hardwired.
what I was saying to myself was, McKenna, I think you're right. I think it's 1. So I think the z-score is 0. And because if you put 0 into the applet, it gives you 1. So there's
Yeah, but then you have to
100%
click
chance.
above. So you'd click to the right. So then you'd get 50%. Because it's
Oh,
greater
yeah,
than
you're
the
right.
mean.
You're right. Yeah, you're right. So it would be above, right?
Right.
So correct. So it's 50. That's what I'm going with.
Okay. So everybody, okay to
Is
go to
every-
23?
23.
Yep.
I got the mean. What's the probability for the 600? I got 0.684.
I got 0.316 because it's below. I think that's 26. 4.
Oh, did I look at the wrong one?
Maybe not because I got my numbers confused on that one.
So real quick, if we do it,
What's your z-score on that one?
the z-score is 0.479.
And how did you get that?
So you do z equals 600 because that's the value they give you, minus 542.3 over the standard deviation, which is 120.54. Does that make sense?
Yeah, I got 0.684 for below 600.
Okay. Yeah.
Because the
And then I
z-score is
think I mixed mine up.
4.499, and you go and you highlight below, and it gives you 0.684.
Okay. And then I think the next one will be.
Hold on here, I'm not
I'm
caught up with
struggling
you
here.
guys yet.
So do you understand how we got the z-score?
You go the 500,
600.
600, less than 542, which is the mean, over the standard deviation,
Sorry,
which is
guys.
120.54. Okay, let me do this here. $600 minus 542.3 divided by 120.54 equals 0.4787. And you put it in your applet. 0.4787. And which way do you shade it?
So when you look at the questions, it says below 600. So you do it the two left various shades because it's below that z-score, the positive z-score.
Yeah, the z-score is positive, so you use the far right line and shade everything to the left of it.
So you shade the middle and the left,
Correct.
Yes.
which is 0.684.
Right.
Okay.
Myra, you're being quiet. Are you getting everything?
Yes, I'm getting. Yeah.
Good.
Question 24. What is the probability that a randomly selected student will score 600 or above on the GMAT?
So with that one, you're going to use the same z-score, but since you're going to go above, since the z-score is positive, you're going to go above that positive number. So that line with the, I'm so bad at explaining stuff. So that right line, do you see how it's a positive 0.479?
I have to get out my stupid juice.
Then you put everything to the right of it. So the very far right one you fill in.
0.316.
Yep.
Awesome.
Did that make sense to everyone?
Uh-huh.
Hold on here. The z-score is 0.4787, and you shade it to the right.
Yep.
My mouse is going crazy. Shade right, because it's positive.
Mm-hmm.
So that would be 0.316.
Correct.
Sorry, I'm just kind of slow.
No, you're good.
0.316.
So for the next one, I got 387.77.
You got what?
387.77. Is that what you got?
That's not what I got, but I didn't really know how to do it.
So for these ones, what you do is when you go to the applet, you start off at the applet.
Yeah, and you
then
put in
for
10.
Yeah, so for the area, you put 0.10.
Uh-huh.
And then this question, you're going to shade, so you shade any less than 50%, so you're going to shade the left side. And then make sure your area is at 0 or 0.10 again because it changes it.
So you shade left?
Just the very far left, not the middle. And then you take that z-score and you plug it back into the z-score equation to find x.
So the z-score I got after putting in 10%, because the area reverts to 0.09999.
Yeah, and then you change it back to 10.
So say that again, McKenna. You're shading, if it's less than 50%, you shade everything to the left too?
You only shade the left.
The far left.
Far left.
Do you highlight the far left and then put in 0.10?
Yeah.
And then that gives us a z-score of negative 1.282.
You've lost me.
Plug it into the equation.
Oh yeah, I got that. That's right. Okay.
I don't got it.
Okay, so let's start over. So you open up your normal probability applet.
Yeah.
And so when you see these percentiles, when they give you the percentiles, you're always going to start with the applet. So you get the applet open, and so now you're looking at it, and since it's less than 50%, you're going to shade in the very far left. Not the middle or the right, but the very far left.
And the question is asking for the 10th percentile.
Right. So then once you shade in the very far left, in the area, you put 0.10 for the 10th percentile.
0.10.
And then you take that z-score that it gives you.
And that's 1.282.
Yes, but since it's the far left, you're going to use the negative. So negative 1.282.
Negative
And
1.
then in your z-score equation, which is z equals x minus the mean over standard deviation,
Yep.
you're going to put your z-score in for z. So you're going to get negative 1.282 equals x minus your mean, which is 542.3, over your standard deviation.
Let's do this, the z-score again. You put your negative 1.282 as your standard deviation.
No, enter that as your z-score.
Yes. Oh, that's my z-score.
So,
okay.
Yeah, so you put negative 1.282 equals x minus 542.3,
542.3,
which is your mean, over
standard deviation.
120.5, yeah.
120.54.
54, yeah. And then you solve it out algebraically.
Hey, I'm back. Oh, I've just pretty much concluded I have horrible internet. So,
Can't you just hardwire it, or are other people using it?
I don't know if my computer will do that because I have a MacBook and I don't think it has the right plug-in.
Never mind that.
So I am right there with you on 27 or whatever number we're on. I got it right, except I didn't use a negative z-score. I used a positive, and I got 696. So that completely changes the algebra with a negative in there. So
yeah, but you're gonna need. That's the answer to the next problem.
Yeah. So I got them mixed up. I got the 387 for the next problem. So.
Gotcha.
All right. So.
I think Wanda's working it out right now.
Okay. So it's 387.768, right? Oh, whole number. So 388. So rounding to the nearest whole number.
Oh, are we? So yeah, 388.
Okay, I'm still working it out because I've got Doryism.
You're good.
Negative 1.282 x. What is my x then?
That's what you're gonna solve for.
Yeah.
So I just
Just write an x.
go through the steps with me, please.
Okay, so you're gonna write negative 1.282 equals
Uh-huh.
x
Yes.
minus 542.3 over 120.54.
Okay.
So then you're going to multiply that 120.54 to each side. So then you're going to get negative 1.282 times 120.54 equals x minus 542.3. Are you with me so far?
Okay. Sorry, my brain's slow.
No, you're good.
I'm timesing negative 1.282 because you want to get rid of the denominator.
Yeah.
Times 120.54. Um, 2.82. Negative 1.282 times 120.54. $463.1.
So then you take.
Hold on here. I'm still doing my calculator stuff here. I'm timesing negative 1.282 times the standard deviation 120.54, which equals negative 463.1. I'm doing the second part of that. 5.423 times 120.54. So your equation would be negative 43.1 equals x minus 6537.
No.
Because you're timesing the 120.54 times the 5.423 to get.
That's just going to cancel out the bottom.
Okay, so it'd be negative 46.3 equals x minus 5.423.
542.3, yeah.
And then you times the 5.423 by both sides.
Add it. Subtracting right now, so you add it to both sides.
Hold on. Let me get my stupid juice out again. My calculator went off.
Garrett.
So you add it. This reminds me of what we learned in Pathways.
I'm making half them. I don't know currently. Go away.
Mommy, this for us? And the rest are for neighbors, right?
So, negative 463.1 plus 5.423. I got 196.
You got something in your math is wrong there.
Well, let me put the answer in and I'll work it out because now I got the equation.
Yeah,
388.
388 is the answer.
On 26, 388. Okay.
And then that's number 27. Or no, number 26.
27 is
25 on the test.
fine. I'm still doing 27. Find the first quartile of the distribution of GMAT scores. Round to the nearest whole number.
No, we're on 25. Find the GMAT score that corresponds to the 10th percentile.
25 is 388.
Oh, yes, because you want to round it up.
And then 26 is 697.
And how did you get that?
The exact same way that we did the last one.
You put the 90% in the area?
Correct.
Mm-hmm.
I like you guys showing me how to do that.
And then you shade above it.
Which way?
So you're going to have the same z-score. It's going to be the exact same z-score, but it's just going to be negative. Because
where are you shading though?
Or positive, I'm sorry, positive.
You shade the far right.
The far right of it. Just the far right. So it's going to be the positive 1.282. And then you do the exact same thing. You plug that equation in. So 1.282 equals x minus 542.3 divided by the standard deviation of 120.54. And then you solve for x. And you get 697.
Give me those numbers again, Brian.
It's
you
the
plug
exact
in the 1282.
Yeah, so it's the exact same numbers from that equation that we used in the previous question.
Yes.
Exact same, except instead of a negative 1.282 like we did in the last one, you do a positive 1.282.
Got that.
And then all the other numbers are the exact same.
X minus
542.3
over standard deviation of 120.54.
Correct. And then you solve for that, and the answer you'll get is 697.
Okay.
Okay. And then 27, I got 461. What did you guys get?
I got 421.76.
Okay.
But I can't even remember how I did this.
That's what I need to know. I need to know how to do it.
Neither. I think I put Would you do it the same way that we just did it on the previous one? So
But it's talking about quartiles.
But the first quartile would be 25%. So could you put in 0.25 for the area?
That makes sense.
And then it's below 50, so shade to the left. So you get negative 0.674 for the z-score, and then solve it again.
Hold on here.
Yeah, that
makes
makes
too fast.
So Wanda, we're doing the same thing that we did with the previous two questions.
You put 25
so
in the
probability app, you're gonna shade the far left first off. Shade the far left, and then type in the area 0.25, and then hit enter.
That's negative 0.674.
So that's our z-score. So the reason we're doing a 25% in the area is because the first quartile is equal to 25% of on the box plot. It's each quartile is equal to 25%.
Yep.
So so we get the z-score, and then we're just plugging it in the exact same equation that we did above. So it's negative 0.674 equals x minus 542.3 divided by the standard deviation of what?
I think we lost him.
But that makes so much sense when he explains it.
Yeah, he's good at explaining.
And it makes sense to do the applet with these. I was trying to do it with some, like the box.
Yeah.
So it's totally off.
Holy smokes, guys.
Okay.
Thank you for bearing with me.
No, you're good.
So for 29 or 30 or whatever that one was,
461.
that's what I got, 461. And then for 28, 624.
Yeah, because it'd be the same way, right?
It'd be the same way except just the positive z-score.
Okay.
I don't know if that's the right way to do it. Does that make sense, though? It kind of...
That does it.
It makes
Yeah,
sense.
it does make sense. Because it's
I get-
the third quartile is the top 75%, which would be the 75th percentile.
Correct.
So I agree.
So it's a third quartile, yeah.
It's above 50, so we shade to the right, get the positive number, and then solve. And I got 623.54, so 624.
So for your z-score, did you get 674?
Correct.
Hold on here. Let me get that into my applet. 0.75. Shade right.
Yep.
0.674.
Yep.
Nope, it's not doing it. 7.75.
So shade it first. Shade it to the right,
Yep.
and then in the area, type in 0.75.
It keeps on shading the middle for me.
Yeah, you need to shade the middle
Ah,
as well.
see, it's smarter than me. So the middle shade and the right shade, and it's 0.74.
Yeah, because you have to shade the middle because it's 50% is included in that 75. So 50% is that center.
Yep. So then
you plug that into the exact same equation that we've been using.
and
So the equation.
29 on the quiz.
What was 29?
28.
29.
28 on the quiz, I got 542.3.
I did as well.
429?
On the quiz, 29 on the quiz.
But I have not completed questions 29 and 30.
Yeah, so 29 on the quiz, the question that reads, consider a simple random sample
Yeah.
of n equals 15. That's the one we're on.
Okay.
What did you get for that one, Wanda?
I didn't know how to do it.
Oh, okay.
So
So,
for, you go ahead.
you're good. I gotta figure out how I. So even though so the mean of the sample means is always going to be equal to the mean. It doesn't matter about the sample size, correct?
Correct.
Right.
So the mean for this question, if you scroll all the way up, is 542.3. So that's the answer for number 29 is 542.3. And then number 30 is the standard deviation. Then we take our standard deviation divided by the square root of the sample size. So it's square root of 15. And I got 31.123.
I did as well.
Can you tell me how to get it?
It's so when we're dealing with the distribution of a sample mean, to find the standard deviation, you take the normal standard deviation divided by the square root of n.
Okay.
So that would be 120.54 divided by the square root of 15, and that equals 31.123.
Because when I put, the top number is 542.3, correct?
No, the top number is 120.54.
That's why I got it wrong.
542.3 is our mean.
No, look, mine's all gone.
Our standard deviation is 120.54.
So the top number to the equation is 542.3 divided by 120.54 square root of 15.
Nope. We're not even. We're totally excluding the mean right now, which is 542.3. Don't even worry about that.
Okay.
We're only trying to find the standard deviation. So the equation for the standard deviation in this question
is n.
No, the equation is the standard deviation divided by the square root of n. So if you scroll all the way up to where it gives us the information for these questions,
Yes.
where it talks about the GMAT score and everything, the standard deviation in there is 120.54.
Yes.
So that's going to be our numerator. That's going to be the top number, divided by the square root of 15, is n. And then that's going to give us the standard deviation of the sample mean scores. So whenever it says the distribution of sample means and you're trying to find the standard deviation, you have to use that equation, the standard deviation over the square root of n, to give you the new standard deviation. Does that make sense, Wanda?
It does. But
awesome.
Can you link it to where you found it?
I could probably find that real quick.
Lesson 7.
7, yep. So the previous lesson.
Okay. Standard deviation over square root of n.
Correct.
So that would be 120 over 15 equals the 31.123.
Correct. And then last question, question 31, is we're finding the probability. So we have to find the z-score. I got 0.032.
Yes.
And that's my 1-year-old screaming in the background. Sorry. Do you understand? Do you guys understand how to find that, Wanda and Myra?
No.
Okay. So this is in lesson 7 as well, the last lesson. Do you want to work through that, McKenna? I got to go grab a charger for my computer.
Yep, I'll work through it. So
Okay.
for that one, so this is like you do everything else. You do the z-score and then you plug it into the probability applet. But this one's a little bit different because it's asking for the sample mean, the probability of the sample mean. So you have to use that standard deviation that we just worked for on the bottom of your z-score equation. And then you plug in 600 for x minus the sample means, which is 542.3. So your z-score, your equation is going to look like this. Z equals 600 minus 542.3 over 31.123. Does that make sense, Myra? Or Wanda?
Yeah.
Okay. And then you solve it out and you get 0.032.
0.032 goes into your z-score on the applet. Do you color it right or left?
Oh, wait.
Well, the z-score is 1.854.
Yeah, sorry. And then you plug it in.
And you plug that 1.854 into the applet.
1.854.
Correct.
Didn't write that one down. And then you shade to the very far right because it's greater than your z-score, your positive z-score.
Someone's happy.
Sorry. So we good? I'm gonna submit it
Me too.
and see how.
So that the answer is 0.4872.
0.032.
0. What?
0.032.
0.032.
Yep.
Oh, we missed 2 questions. We got a 93.5. Let's see.
Oh, it's that one.
Dang it. So it's that one, and then
It's which one?
The 50%, the number 22. I'm gonna email the tutor about that one because that's the same one we missed on the last one, I think.
yeah, and I was wrong on number 13 as well. So I
I'm wondering if
apologize.
it's variance.
Is it variance?
I don't know. Maybe I'll
What
just email
question?
both about those.
Ah,
Yeah, because
Let me write
I don't
down the
understand that one. That the
22, right?
50% or whatever.
That's
Number
22.
22. Yeah, number 22.
Yeah. Did you get that one right, Myra? Did you know how to do that one?
Maybe we have to put it like on decimals, I think. Like 0.5.
Oh, that might be
Oh.
true.
Oh, I wonder.
I didn't submit it yet.
I bet that's right. Yeah, you haven't submitted yet.
No, maybe right now.
0.5. I bet that's. I hope that's right, because then that would save a lot of a lot of brain power. We already figured it out.
Yeah.
so 22, 0.363 was wrong.
We put 50% in there. 0.5.
Yes, it was 0.5.
It is 0.5?
That makes me
Awesome.
feel good. Yay.
Woo!
Okay. Oh, I feel better about this test now.
Me too. So Wanda, that one, let's go through that real quick for you.
Okay,
22.
okay.
So
What is the probability that a randomly selected student will score above 542.3 on the GMAT?
okay, so we're gonna. So the equation for this is x minus the mean divided by the standard deviation, correct? So this in the question, this 542.3, that is the mean. It's equal to the mean. So we're taking 542.3 minus 542.3, which gives us 0. So ultimately the answer, no matter what, if you divide 0 by anything, it's going to be 0.
Mm-hmm.
So we get 0, and then we put 0 into the probability app for the z-score.
Mm-hmm.
And then we're shading above because it wants to know in the question.
When you say above, what does that mean?
Because in the question it's asking
Above 542.3.
if they score above 542.3. So if we put 0 in as a z-score, there's just going to give us one line, and we shade above that one line, and that gives us 50 or 0.50.
Above is to the right and below is to the left.
To the
when you're
left.
looking at it.
So in my area, I'm putting 0.
No, your z-score you put 0.
Yeah, your z-score is 0.
Oh, my z-score. Okay. And it gives me 0.5. Okay.
Yep. And then, do we know if that other one was variance?
I don't know. I will email the tutor and I will email you guys the answer.
Okay.
I wrote down the question, so I'll just email it to him. Hopefully we'll get an email back soon, and then I can pass it on to everybody.
Deal.
But on question 22, do we take it out to the third?
Just put
Or is it just-
0.5.
Is that it?
Right, Myra? You put 0.5?
Yes, it was 0.5.
Okay, cool. All right. Any other questions?
Yay.
On the other one that we missed. What do we need to do to?
Yeah.
I'm going to have to look that one up. She's going to, McKenna's going to email the tutor and ask about that question. She'll let us know. The other one we missed.
I'll send you the question and the answer in a text message when I find it.
Okay.
Okay.
All right, guys.
Thank you
Back on
guys
the
for your help.
test.
Oh, I dropped my calculator.
Okay.
Good luck.
Good luck on your final, on your midterm.